Alright, are we cooking? Are we cooking? Are we cooking? Are we cooking? Wait, fuck. I need to... Okay, bestie, I'm not gonna lie. Optimization was, like, the scariest unit ever. Yeah. Let me tell you why. It's because, I don't know. I think it's because there's word problems, and it makes it really scary, but it's gonna be the same steps every single time for every single one. No matter what kind of question it's asking you to optimize. Wait, what the fuck does optimization mean? Optimization is when a question asks you to find the smallest thing possible or the biggest thing possible. So let's just go over the steps. Okay, step 1, it's going to be the same step for every single one, and this is honestly the hardest step. Identify constraint and what you want to solve for. Okay, so the constraint, what the hell are we talking about? Okay, the constraint is going to be whatever they give you. There's going to be a number that they give you. It's either going to be like a function or there's going to be a number. Wherever you see the number, that's what the constraint is going to be. So in this case, the constraint is 1,200 centimeters of material is available to make a box with a square base and an open top. Like, oh my god, why does it have to be so complicated? That's your constraint. So the first step is to identify a constraint and what you want to solve for. Then it says find the largest possible volume of the box. Okay, so we know it's going to be optimization because it's largest possible volume, period. So now we have to write down the functions. Let's start with the constraint. 12,000 centimeters of this box with no top and a square base. So it always helps to draw a picture. So here's a box and there's no top. That's important. Now we have to come up with the constraint. What does this little box, like, let's write down all the sides that it's going to make up. So it's going to be 1,200 centimeters total. And that's going to include the square bottom, so this is the bottom with x's and squares. So this little plane right here is going to be x times x. Then we have 4 of these rectangular sides here. And the area of that's going to be x times y. But it's going to be, there's 4 of them. So 1,200 is equal to this x squared, this bottom, plus 4 times this rectangular thing. Okay, don't panic. This is like the hardest step, pretty much. So now we have our constraint function, and then we need to solve for what is the largest possible volume. So now we have to say, okay, what do we want to solve for? Well, it's asking us to solve for volume. So the volume of this box is going to be x times y, right? This side times this side times this side. So it's going to be x squared times y. Okay, this is literally the hardest step of the entire thing. So okay, what's the next step? I don't know, let's find out. Okay, solve for x or y in the constraint function and plug it into the other function. Look at the constraint function. This is our constraint function. And now we need to solve for one variable. So let's solve for y, because that's going to be easier. So solve for a variable. We subtract this x to the other side. Divide by 4x. And that's going to equal y. Okay, so now that we've solved for one variable, see how like the two letters are on completely different sides? Like there's no x's on this side, there's no y's on this side. Okay, now we can plug in this y into the other function, which is the volume function, x squared plus y. So we can plug this in for y right here. Okay, let's simplify this. These x's cancel out, except this x is left alone, and there's still a 1/4, and the rest is, we know the rest. Now we can simplify this a little bit by multiplying the x through the whole thing. Okay, so now, what's the next step? We have to take the derivative of this. Again, just memorize these steps. It's not super intuitive, like you wouldn't really know to do this, but it's the same steps for every single one. Okay, so let's take the derivative. Take the derivative of this. Okay, so the 1/4 is going to stay the same, and then that x is going to go away, bring the 3 down, bring the 3 down, 3x squared. Cool. Next step, set derivative equal to 0 and solve. Okay, well let's get rid of this 1/4 by multiplying by 4 on both sides. It's going to get rid of this, and 4 times 0 is just 0. Add 3x squared, divide by 3, 400, take the square root. X is going to be equal to 20. Yeah. Okay. Wait, we're so close to being done. Okay. So, now that we have one of the x's, we can plug this in to the other function, this function, and solve for the other variable. So, the other function is a constraint function. When we plug in x, we get this. Now we can just solve her out and find that y is going to be 10. So your last step is plug in the two values that we found, 20 is equal to x and 10 is equal to y, into what you're actually trying to solve for, which is what? I don't even remember.
Bruh.
Find the largest possible volume of the box. Okay. Plug it in to the volume function, x squared plus y. Okay, well x is 20, so 20 squared times y, 10. Solve it out. 400 times 10, 4,000 centimeters cubed. Boom. Okay, so that was kind of confusing. If you're really panicked right now, it's okay. All you need to do is memorize these steps and do the same thing every single time. Don't second guess yourself. It's literally the same steps every single time, even if the questions look a little bit different. So most of your tests are going to ask a similar question to this, where it's like, what is the area of something, given you have 400 yards of fencing, or something like that. But we're going to look at other questions that they ask that make it a little bit more tricky, a little bit more challenging. So let's look at that right now. Round 2. Let's fucking go. Okay, find two numbers whose difference is 100 and whose product is a minimum. Who's scared? Who's scared? Raise your hand if you're scared. Okay, I'm a little scared too, but it's fine. We can do it. Okay, steps. Identify constraint and what you want to solve for. So, identify constraint. Remember, the constraint is going to be whatever numbers they give you. So, we have to create a function for a number that they give us. So, they give us 100 and says, okay, find two numbers whose difference is 100. Difference. Oh my god. What a politically charged word. Okay, difference is subtraction. So, two numbers subtracted are going to equal 100, and whose product is a minimum. So that's what we're trying to solve for. We're trying to find the minimum of a product. Again, optimization is all about minimums and maximums. So we want to find the minimum product. Product means multiplication, so x times y. Okay, what's our next step? Solve for x or y in the constraint function. This is the constraint function, and plug that value into the x times y. So, okay, bestie, which one do you want to solve for? I think let's do this. Now we plug this in to a product function. Don't ask me why, that's just the way it is. Okay, simplify, it'll make it easier because the next step is to take the derivative. Okay, so here's this. Take the derivative, ready, go. Wow, that was easy. Okay, set it equal to 0 and solve. Okay, easy enough. So now we get a number here. Negative 50 is equal to y. Now that we have one number, our next step is to plug it into the constraint function and solve for the other variable. Sometimes people are so silly and they plug it into this function So if that happens to you, if you accidentally plug it into the wrong function, you're gonna know because you're not gonna get a number. So if we plugged it into this, we would get
P is equal to x times negative 50.
And then when you solve for x, it's gonna be like
1 over negative 50 times P is equal to x.
it's just not gonna work. So you know that you fucked up, basically. Let's plug it in. Boom, boom, boom. X is equal to 50. Okay, so now we have an x and a y. And now we have to plug it into what we're trying to solve for. Wait, find two numbers is actually what we're supposed to solve for. So find two numbers, boom, we just did it. The product would be 50 times negative 50, which is, oh god, I don't even know. No, negative, I think this is it. This is the product. Okay, period. Let's do another. Okay, bestie, find the point on the parabola y is equal to 2x that is closest to the point 1, 4. What the fuck? This looks way different than normal. Okay, but it's the same steps. First step, identify constraint and what you want to solve for and write them down, bitch. Okay, first step. The constraint is something that they give you, right? The numbers that they give you. In this case, they give you y is equal to 2x. So, what the hell? That looks like a crazy constraint, but that's just how it is. Then it says, okay, what do you want to solve for? Well, we want to solve for distance right here. It's closest to the point 1, 4. If it's closest or furthest away from something, you're solving for distance and you need to memorize this formula.
Bruh.
This looks horrifying, I know, but it's just something that you need to memorize. If you are solving for distance, you need to memorize this. And you're going to know that you're solving for distance if it's closest to or furthest away from. Next step. Okay, well, from the point 1, 4. So this x1 and this y2 or whatever, 1, 4 is going to go in here. So this is your distance function. Boom. Next step. Okay. Solve for x or y in the constraint function and plug it into the other function. Okay, so easy. Boom. We just solve for x by dividing by 2. This is our constraint function. And see how this used to be an x? Wow. Now it's a 1/2 y squared. Next step, take the derivative. Okay, so taking the derivative of this is going to give me a headache. It's going to be easier if we take the derivative of this. Now, why can we do this? We're solving for a minimum of a square root, blah, 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 blah. And that's why we have to take the derivative. But the minimum of this is going to be the exact same as this squared. Wow, this looks like hieroglyphics. But if we square this, it's still going to be the same minimum. Like if we have numbers 2, 4, and 1, and we square all of them, it's going to be 4, 16, and 1. 1 is still the minimum here. So we can square this and take the derivative of just this so we don't have to worry about this horrible square root. Okay, so let's do it. We're going to take this derivative. So first one, chain rule. We bring the 2 down, leave the middle the same, subtract 1, that's just 1 up here. Then we have to multiply it by the derivative of the inside. The derivative of the inside is just y, because this 2 cancels out this 2 here. Okay, plus, again, derivative, 2 times y minus 4. Okay, we're done. Now we're going to multiply this 2 and this y, distribute it into here. So it's going to turn into this, plus 2y minus 8. Okay. Simplify a little bit. Okay, next step is set that derivative equal to 0. Okay, what multiplies 3 times to get 8? Did you say 2? Probably not, but that's the answer. Use this answer, as y, to plug it into the constraint function to solve for the other variable. Okay, what's our constraint function? There it is. So 2 squared is equal to 2x, 4 is equal to 2x, 2 is equal to x. So now look. We have an x and we have a y. Plug values into what you're needing to solve for. What are we trying to solve for? We're trying to solve for a point on the parabola that's closest to a certain point. So now we have a value for x and we have a value for y. So we literally just plug it in and that's the point that is going to be the closest. Fascinating stuff. If you want more help on this, hit me up for math tutoring. I will literally tutor you, and I promise you won't fail calc. Okay, bye!